I'm thinking, you think it's hard to see behind my smile.
Now we have gotten a table of values, and these are the questions we have to sort out. We have to plot the graph, but we don't have the standard graph. We are just using a sketch of the graph to understand how it will go. First thing you do is you write your word date. Write the title. A graph of I in ampere against V in volts. Then take your Cartesian axis. Label your Cartesian axis. I'm labeling my own. That means here is my I in ampere and here is my V in volts. Then I'm to choose appropriate scale. They didn't specify that we should start from the origin, so we have to choose either from the origin or without starting from the origin. Now considering what I have here, the least in the I axis is 0.5 and the least in V is 0.75. So not starting from the origin, we make it to balance well. Like I will write 0.5 here and write 0.7 here. This is for horizontal and this is for vertical. And I'll bracket it. Horizontal and vertical. Here I'll be using 0.7. Wow, I'll be using 0.5, 0.6, 7, 8, 9, 10, 11. Okay. I will use 0.6 and put here 0.7, 0.8, 0.9, 1.0, 1.1 and 1.2. Then for here I'll be using 0.7, 0.9, 1.1, 1.3, 1.5, 1.7, 1.9 and 2.1. Then that means I'm using 2 centimeter for horizontal, 2 centimeter for 0.2 volts, 2 centimeter 0.2 volts. Then this is 2 centimeter 0.1 volt. Are you getting it? And so that is about what I use here to see that it balanced well in the graph. Then I will now say 1.2 against 1.8. 1.2 against 1.8. 1.8 should be in between 1.7 and 1. So I will put here 0.9 against 1.4. 1.4. Then 0.7 against 1.1. 1.1. 0.55 against 0.8. Here is 0.7, 0.8, and here is 0.55 in between. In between here and 0.5, you have 0.55. So 0.8 should be this 0.5 half. 0. This is 0.5, so 0.55 should be somewhere here. Then this 0.9, 0.8 should be here. Then 0.5 against 0.75. Here is 0.5 and here is 0.7. 0.7, 0.8. So here is 0.7. I'm looking for 0.55. Here 0.8. Here is 0.7. Here is 0.8. So 0.55 should be somewhere here. Then I'm to locate it with 0.5. 0.5. Here is 0.5. Okay, we've gotten 0. Here is 0.55. Here is 0.55 against 0.8. 0.55 against 0. Here is 0.8. Please, this size, this is 0.55 against 0.8 is here, like they have. Look at 0.8 and look at 0.55. So they will intersect here. So we have located our points. You can see a direct relationship. Next is for us to put our words line of best fit so that we can get our slope. Now we have succeeded to locate our line of best fit. Remember we said for you to get perfect line of best fit, you have to get the mean of your words, vertical axis, and mean of your horizontal. When you get their mean, plot it to get your centroid. That is what you see I circled here. Are you getting it? I say 1.2 plus 0.9, that is this one of current, plus 0.7 plus 0.55 plus 0.5 divided by, how many are there? 5 readings divided by 5 to give you 0.8 approximately. Then you do the one of V on 1.8 plus 1.4 plus 1.1 plus 0.8 plus 0.75 divided by 5 to give you 1.2 approximately. So look at your 1.2 and look at 0.8. That will tell you the perfect points where your line of best fit should pass through. So we have gotten our line of best fit. It must pass through that centroid. It must pass through that word centroid. So when we are done with that, we have to get our word slope. To get our slope, you see, we now say change in I and change in what? V. Change in I and change in what? V. Change in I, what is the highest? Since here is 1. Okay, this is 1.1, this is 1.2. We will take care to be 1.12. We are using a sketch of graph, so use your perfect graph to work, to do this plotting. Then take here is 0.6. Take here 1.7. Take here. So since here is 0.8 and here is 0.9, 0.85. We say slope is equals to change in what? I all over change in what? V. Please don't forget to include your scale. Please, if you watch any of my video where I forgot to put my scale, please take that correction. Put the scale, don't forget it. I axis, in I axis we have 2 cm represent 0.1 ampere. In V axis, 2 cm represents 0.2 volts. You include it so that the graph will look sweet. This minus this, 1.12 minus 0.6. 1.12 minus 0.6 will be giving us 0.52. All over 1.7 minus 0.85. 1.7 minus 0.85 equals to 1.7 minus 0.85. 0.85. So you'll be having 0.52 divided by 0.85. You will be having 0.61. 0.61 ampere over what? Volts. The unit of current is ampere, the unit of volt is volts. So we say take this 1.12, take this 0.6, and take this 1.7, take this 0.85. So that is to make sure that we have correct. Okay, so that is what we got from this sketch of graph. You have to use the standard graph to what? Do your own and see what you could get from it. Okay, I've gotten our slope. They say find the standard error in the slope. Wow. To get the standard error in the slope, we take that point that fall out with the centroid. Watch it. Look at the point that fall out. We take it with the centroid. So when we take it with the centroid, we'll be getting its slope. We have to get its slope. We get the slope. We get the slope to be we get this. Then this is 1.0 minus this is 0.7. Then for horizontal, this is 1.3, 1.5. So this is taken to be 1.4 minus this is taken to be 1.1. Are you getting it? Slope of worst fit. Change in I over what? This is for the best and this is for the worst. Change in V. This minus this 1.0 minus 0.7, 1.0, 0.7, 1.4, 1.1. All over 1.4 minus 1.1. That will be giving me 0.3 over 0.3. That will be equal to 1 ampere over what? Volts. 1 ampere over volts. Now their error in slope will be equal to change 1 minus 0.61 modulus. That will be equal to 1 minus 0.61. So that means get the difference of the one of line of best fit and the one of line of worst fit. Get the difference. If the difference is negative, take the modulus. Now make it to be positive. That will be equal to 0.39. That is error in the what? In the slope. We have gotten the error in slope and the slope. Therefore, we package our slope as 0.61 slope equals to 0. Plus or minus 0.39 ampere over voltage. 0.61 plus or minus 0.39 ampere over voltage. Use a standard graph sheet to do the plotting and get your right answer. Okay, this is just a sketch of graph. But when you get this, if the marking scheme say the value is 1 ampere over volts, the implication is that if this is not in the marking scheme, this plus this will be in the marking scheme, or this minus this. So either of these three, one must be in the marking scheme. Either this exactly, or this plus this, or this minus this. That is how we do it. Okay. So we have gotten our error, and we have seen how to package it. Now, given that V equal to IR, where R is the resistance of resistors, use the result of the experiment to determine the value of R. To determine the value of R, you tell them that since we plotted the graph of I against V, this sign of proportionality is placed with equal to K. Are you getting it? Where this becomes your what? Slope. That K becomes your slope. So we say, since this K replaces 1 over R so as to obey Ohm's law, which says that V equal to IR. I times this, IR. To obey it, the K have to be equal to 1 over R. Are you getting it? That means K is equal to 1 over R. Our K is equals to 0.61. 1 over 0.61. 1 divided by 0.61. We have it to be 1.6 ohms. You have your R to be 1.6 ohms. Okay? Now, if you want to get the standard error in R, you say standard error in what? R. Standard error in what? R. Standard error in R is equal to R times square root of. Since R is equal to 1 over K, that is K inverse, you say minus 1. This means 1 over K means K raised to power minus 1, K inverse. So carry that minus 1, put it here, times what? Error in K. What is the error in K? We got the error to be 0.39. 0.39. Since our K is the slope, the error was 0.39. We say 0.39 all over. What is the K? K means the slope. Slope is 0.61. 0.61. So that means the formula for this is R times square root of the power of K times error in K, all over K, all what? Squared. All squared. Okay? That means power of square root will take care of the power of 2. We will be having SR to be equals to R is 1.61, 1.6 times minus 1 times this. Minus 1 times this. Before this minus 1, you know, when we square this, when we square minus 1, you'll be having 1. Square this, you have it. Square this, you have it. So this will now be plus because of that power of 2. Power of 2 will clear that minus to be what? Plus, and still have the power of 2 there, so as it will take care of the word square root. And so we now say 1 times 0.39 all over 0.61. This minus change to plus because of that power of 2. So we now press it in our calculator. We have 1.6 times 0.39 times 1 divided by 0.61. Divided by 0.61. That will be giving you 1.0. SR is equal to 1.0 watts. 1.0 ohm. 1.0 ohm. Therefore, that means that your R is 1.6 plus or minus 1.0 watts ohm. R is 1.6 plus or minus 1.0 ohm. That means either it is 1.6 ohm or 1.6 plus 1 ohm or 1.6 minus 1 ohm. That is your what? R. equals to your R, where this is the error in the R and this is the R itself. Okay, we'll go to the last question. To solve the last question, a cell of EML supplies current of this to an element whose resistance is 1.5 ohm. Find the internal resistance of this. We said that E is equal to I bracket R plus R, where this is the internal resistance and this is R. Therefore, E equals to IR plus IR. This goes here. E minus IR all over I equal to R. What is your what? E. E is 3 minus IR. 1 times R. 1 times 1.5 is 1.5. All over I. I is what? 1. That will be given. 3 minus 1.5 is 1.5. Divided by 1. 1.5. 1.5 ohm. That means the answer to that B is 1.5 ohm. That is where we stop for today's experiment. Thanks for watching the video. Please don't forget to click like button, click subscribe, share to your friends, and comment on questions you have. But please note that this minus, that should be the power of this scale. The minus is changed to plus because of this power of 2. And still finally, power of 2 will take care of this square root. That means square root bracket 1 minus 1 times 0.39 over 0.61 all square will still give you this. Just press your calculator and sort it out to confirm. Okay? Thanks for watching today's video.